A sample from Mars is found to have the empirical formula of CH2O, and its molar mass is 150.1 grams per mole. Find the molecular formula of this Martian sample. So let's start with CH2O and find out the molar mass based on that empirical formula, then scale as needed. I'll mention the fast way of doing it, and then I'll do it out in detail. Each carbon checks in at 12 grams per mole, hydrogen at 1, and oxygen at 16. So totaling them up, we get 12 plus 2 is 14, plus 16 is 30. We're going to have to scale by a factor of 5 to get to 150.1, so the answer will be C5H10O. Excuse me. So let's go ahead and do that out in a little more detail. Looking at your periodic table, you should see that carbon is right here, and you should see the number 12. I'm rounding to the nearest whole number. It just makes things cleaner. Each hydrogen checks in at 1 gram per mole, and oxygen at 16 grams per mole. So this would be 12 plus 2 times 1, see how there's two H's, plus 2 plus 16 equals 30 grams per mole. 30 grams per mole is not the molecular formula. The molecular formula is always a multiple of the empirical formula. And if you multiply that by 5, you get 150 grams per mole. So CH2O times 5 equals C5H10O2. You could also, if you needed to, put the molar mass, that's the molecular weight, divided by the empirical formula, which is 30 grams per mole. And that's going to give you the scaling factor. In other words, I'll put it over here. Molecular formula. I don't do it this way, but it might help you. Divided by the empirical formula. Equals the scaling factor. And there you go. And so in this case, it's 5. Multiply everything times 5, and you get the answer. This is an empirical formula to molecular formula question.